Hi everyone, today let's talk about session 3.4, derivatives of trig functions. Big idea. The shortcuts of taking the derivative of the 6 trig functions is to memorize the formulas in the table below. Big skills. You should be able to take the derivative of functions made up of combinations of the trig and power functions. So this is our table, okay? So derivative of sine equals cosine x. Derivative of cosine equals minus sine x. Derivative of tangent x is secant square. Derivative of cotangent x is minus cosecant square. Derivative of secant is secant tangent. Derivative of cosecant is minus cosecant cotangent. So you might want to ask, okay, how do I memorize this? Well, let me share with you some trick, okay? So, let me see. Okay, so think about cosine and sine, they are couples. So, cosine and sine, they are couple. Okay, then the derivative of sine is gonna be cosine. Derivative of cosine is related to sine, okay? So think about their couple, so the derivative of each of them is like the other one. And then you think about the tangent and secant and another secant. So, wow. Now this is more special. So it's like you have one husband and 2 wives. Maybe in some other countries you can do that. Okay, so but anyway, think of them are like a couple or a family together. So that's why the derivative of tangent, what's the family members of tangent x? Well, that's secant square, right? So you see secant square. And then what is the derivative of secant? Well, what's the family member of secant? Well, that is secant and tangent. Right? So this is, this trick can help us to memorize the top one. Okay? The top 3, we can use this trick to memorize. And as long as you memorize the top row, the bottom row is so easy. The bottom row is just minus co of whatever on top. Okay? So you can think of, oh, this is negative co. You can think of cosine is like sine. It's like 2 negative, make it positive. So the derivative of cosine is minus cosine is like sine, so it's minus sine x. The derivative of cotangent is minus cosecant square. Right? You see this rule? Minus cosecant square. The derivative of cosecant is minus cosecant cotangent. Right? So with this trick, hopefully you can memorize those 6 formula. Okay? Again, how do you memorize the top row? Okay, you think about cosine and sine, they're coupled, so the derivative of sine is cosine. And then you think about tangent and secant, so there are 2 secants. Okay, so they're in a family. So what are the family members of tangent? Well, that's secant square. What are the family members of secant? Well, that is secant tangent. Right? After you memorize the first row, the second row, the derivative is just negative whatever on top of that one. Okay? So derivative of cosine is minus sine. Okay? Derivative of cotangent is minus cosecant square. Derivative of cosecant is minus cotangent, cosecant. Okay? Yeah, very easy, right? Okay, so before we can prove these derivatives, we need to establish some helpful limits. Because we stumble upon them in applying the definition of the derivative to the sine function. So this is the proof of finding the derivative of sine. We use the limit definition. Okay, that's the limit. H goes to 0, sine of x plus h minus sine x over h. Okay, and then here, what is sine of x plus h? Well, we have the formula. Well, that is sine x cosine h plus sine h cosine x. Okay, so now you can see, wow, this term and this term, they both contained the factor of sine x. So let me group them together. So we group them together, and then this guy, we split them and put it there. Okay, and now we can factor out the sine x, because this is a limit of h. Sine x is like a constant term. It has no h in it. So we can factor out the sine x and put it outside of the limits. Then we get this cosine h minus 1 over h. And this is cosine x is it's like a constant. It has no h in it. So we can also put outside of the limits. So that's why we have cosine x and we have the limit sine h over h. So right now, we want to figure out what is this limit and what is this limit. Okay, and later on, I can prove to you that the limits of sine h over h when h goes to 0 equals 1. So this guy equals 1, and I can show you the limit h goes to 0, cosine h minus 1 over h. This guy goes to 0, okay? So that's why when we find those limits, well, we can plug in sine x times 0 is 0, and then cosine x times 1 is cosine x. See, that finished the proof. We just proved that the derivative of sine x equals cosine x. So far, so good? So right now, let me show you, let me prove to you why the limits, okay? So this is a theorem, the trig limits. Limit x goes to 0, sine x over x equals 1. Limit x goes to 0, cosine x minus 1 over x equals 0. Okay, so if you want to plug in 0, you will realize, okay, remember the steps we did in chapter 2, when we see a limit, we try to plug in a number. And then when you plug in it, you get, oh, sine 0, 0, and then x is 0. So 0 over 0, what does that mean? Well, that means there's a bad guy, right? But however, sine x is not a polynomial. You cannot really factor out the bad guy. And it's not a difference of square roots, so you cannot multiply by its conjugate. It's not fraction, so you cannot combine the fractions into a single fraction and then simplify it. We can do that. Sine x is not any of the kind that we learned. So here we actually need a special technique, okay, to prove it. So by the way, this is the graph. This is the graph of sine x over x. And you can see when x goes to 0. So even though the function is not defined as 0 because the denominator cannot be 0, right? So you should have like open circle right there. But the limits, you can see the limit is approaching to 1. Okay? All right. So in order to prove this theorem, okay, we're gonna need the unit circle. Remember the unit circle? That is centered at the origin with radius 1. Okay? And then we're gonna consider two triangles. So we're gonna consider the triangles OCD. What is special about this triangle? Well, you can see OC is 1. Right? We also consider the triangle OAB. What is special about this triangle? Well, you can see OB is 1. Okay? Because any points on this unit circle, the distance from the point to the origin is 1. Okay. So, let's see. Okay. So, I want to compare the area of the triangle OCD and the sector. So OCD is here, right? And the sector OCB and the area of the triangle OAB. Okay? Which one is biggest? Which one is smallest? So we can see the area of triangle OCD is smaller or equal to the sector OCB, right? everybody, and it's less than equal to the area of the triangle OAB. You can see this is OCD and this is OCB. The biggest is OAB, right? Can you see that from the picture? Okay, so and if we let x goes to from 0 to power 2, this is always true, okay? And let's continue. Let's compute the area of each of them. What is the area of OCD? Well, let's see. So OCD, you know this angle is x and this OC is 1. So we want to compute the how do we compute area? 1/2 base times height, right? So we want to compute the base and the height. So what is OD? Well, OD we know that OD over OC, well, that is OD over OC is the adjacent over hypotenuse. So that is cosine x. And because OC is 1, so this guy is just OD. OD is cosine x. Alright. And how about CD? Well, CD over OC, this is opposite over hypotenuse, so that's sine x. And because OC equals 1, so CD equals sine x, right? I ran out of space, so let me make more room here. Oops. Okay. So what is the area of OCD? Well, that is 1/2 base. Base is OD. OD is cosine x times height. Height is sine x. Okay, that's the area of OCD. How about the sector OCB? Well, do you remember how to compute the sector? So area of sector, okay, if you have radius r and this is angle theta, the area of the sector equals 1/2 theta r squared. Okay, and well, why this is true? You can think about, okay, how about the whole circle? Well, the whole circle is pi r squared, right? But you can think about what's the angle of the whole circle. Well, that's 2 pi. So 2 pi over 2 r squared. You see? 2 cancel, we get pi r squared. So this formula for sector is true. Okay, and then because our radius is 1 and our theta is just x, so that's why the area here is just 1/2 x. And then next, what is the area of OAB? Okay, what is OAB? OAB, we know OB is 1 and the angle is x. Okay, so in order to find the area, we need base and height, but we already know the base. Okay, how do we find the height? Okay, we know OB and we're looking for AB. So what's the relationship between AB and OB? So AB over OB, that is opposite over adjacent. That is tangent x. So, and OB equals 1. So that's why we get AB is tangent x. Alright, so that's why the area of OAB is 1/2 base. Base is 1. Height is tangent x. So far, so good, everybody. But what is tangent x? Tangent x is actually sine x over cosine x, right? You can see this inequality, all of the terms have 1/2. We can multiply by 2 on each of the term. It won't change the inequality. Okay, can you see the left term, we have sine x. The right term, if we solve for sine and cosine, we also have the sine x. So let's divide it by sine x on each of the term. Then we multiply by 2. Then we get cosine x less than equal to x over sine x less than equal to 1 over cosine x. Alright, does this seem familiar? Well, do you think of like something bounded by 2 boundary functions, and that is squeeze theorem, right? So we compute limits x goes to 0 cosine x. Well, that is 1. And when we compute the limits x goes to 0, 1 over cosine x, 1 over 1 is also 1. Woo! The two boundary functions have the same limits. Then, by the squeeze theorem, the middle guy must have the same limits. Oh, and what we're looking for? We're looking for the limits. Sine x over x. Well, that is 1 over x over sine x. So this is also 1 as well. So far, so good, everybody. Okay, so we have already showed the limits of sine x over x is 1. How do we show this guy? Okay, so let me show it here. Okay, so how do we show this guy? Okay, limits x goes to 0, cosine x minus 1x. So we already know the limits of sine x over x is 1. So can we change this in terms of sine? Yes, we can. So this is actually similar to the difference of square roots. You can multiply by its conjugates. What's conjugates? Well, you have the same, the root terms are the same, but the middle sign, you flip them. Okay, you flip the middle sign. Okay, and then we have cosine squared minus 1 over x times cosine x plus 1, okay? What's cosine squared minus 1? Well, that is actually, if you can remember, sine squared plus cosine squared equals 1. So that's why cosine squared minus 1 is negative sine squared. Okay, now what do we do next? I'm gonna split it. So how do I split it? I want to put it aside. Sine x, I want to match with the x. I want to put them together. And then I still have the sine x. And I have the cosine x plus 1. So this is how I split it. Now, when x goes to 0, this guy goes to 1. This guy goes to 0. Oops, this guy goes to 1. And cosine 0 is 1, so this guy goes to 1/2. Oops. Okay, so that's why 1 times 0 times 1/2, the answer is 0. Okay, so that's the proof of the theorem. Okay. And here we have couple remark. So we mark when x goes to infinity, sine x over x is 0. Why is that? Look at this picture. Well, that's the squeeze theorem, remember? Sine x is bounded between minus 1 and 1 when you divide it by x, okay? See? When you divide it by x. Well, minus 1 over x, when x goes to infinity, this guy goes to 0. 1 over x, when x goes to infinity, this guy also goes to 0. So also by squeeze theorem, this limit is 0. So that's why you need to be careful. You need to look at where the x is approaching to. Okay? So read the problem carefully. Alright. So now, how do we use our theorem to evaluate the limit? Okay, so right now, after we prove the theorem, I want to tell you that, okay, it's not only x, it's any u, okay? So first of all, do you think this is true? Yeah, it's like we just replace x by u, we just call it a different name, right? But it's still the same thing, right? So, okay, now u can be a function of x. As long as u also goes to 0, then sine u over u is gonna be 1. So, for example, okay, limit x goes to 0, sine x squared over x squared. What is this guy? Well, sine x squared, well, it's like the u is x squared, but when x goes to 0, the u also goes to 0. So this guy is 1. Okay? And furthermore, how about when x goes to 0, sine of square root of x over square root of x? Well, u in this case is square root of x. When x goes to 0, u also go to 0. So this is 1. So as long as a function that is going to 0 when x goes to 0, then sine u over u is gonna be 1. Okay, so that generalizes to many functions instead of just x. Okay, and the steps how to solve the following problems. Okay, so remember when we learn the new kinds of problem, I would like to show you the steps. And I want you to learn this study skills. When you see a problem, summarize the steps. Then you learn one example, you summarize the steps, then you know how to solve all examples of the same kind. Okay? So, I would say first steps, your functions, if they're not in terms of sine x, change it in terms of sine and cosine. Okay, change it in terms of sine and cosine. And second, we're gonna split the factors. 3, we're gonna do the matching game. Okay, what is matching game? If you see sign of something, you want to match the something under it. Okay, match them together. Okay, and then 4, we can evaluate. Okay, so let's see our example. Okay, so we would do a lot of examples, then you can get the idea what I mean. Okay, so first steps. Well, it's already in terms of sine, so okay, that's good. And then next, we're gonna split the factors. So how do we split the factors? Okay, I get sine 5x on top, and I have sine 3x in the bottom. See, I split them. Okay, next, we're gonna do the matching game. Matching game, let me use a different color. Okay, so here, what do you want to match here? Well, remember sine u, you want to match the exactly u there. So you want to divide it by 5x. But you cannot just divide it by 5x. If you divide it by a number, you also need to multiply by that number so that the expression is not changed. Okay, it's still equal. So far, so good? I strongly recommend you to use a different color. Then you can see, okay, the orange color or your pencil is what you already have. And then the blue color, you can use a different color, maybe red or so other than the pencil. It's something you added to it. I mean, yes. Okay, if you divide it by 5x, you need to multiply by 5x at the end. And here, what do I need to match here? My u is 3x, so I want to multiply by 3x. But I also need to divide it by 3x, so I'm not changing anything. Right? So after we match, we can evaluate the limits. Sine u over u when u goes to 0 is 1. U over sine u when u goes to 0 is 1. Here, you see the bad guy x? Cancel it. Then we have 5 over 3. Oh, the limit is 5 over 3. So far, so good, everybody? You see, follow the steps. Then we can solve the trig limits. Okay, let's continue. What is the first step? Well, check. Are they in terms of sine and cosine? Yes. Okay, then what do we do next? We want to split them. So how do we split? We have sine 4x squared and the bottom. So this guy is one term. Okay, I'm so worried about students will do, oh, sine x and 4x squared. No, it's not multiply. It's sine of 4x squared. And then the bottom, I have sine 7x. Actually, I have 2 copy of that. Because this square. You see the difference between this square and this square? The top square is inside of the sine. It's only one term, one factor. But the bottom, you have a parenthesis around it. So it's actually 2 factors multiplied together. So we can split it. So we split the factors. And then we do the matching game. So don't forget to change your color. Yeah, so I really hope don't be lazy because the problem can get harder. I strongly recommend you to change the color because some students they don't change the color, but when the problem's getting more and more complicated, they forgot what are the factors they added to it, and then for example, if they divided by something, they forgot to multiply by that thing, so which is not good. Okay, so I would strongly recommend you to have a different color pen, and when you match, please use a different color. Okay, so here, what do we want to match? I want to match the same u, so 4x squared. If u divided by 4x squared, you also need to multiply by 4x squared, right? Here, what do you want to match? 7x. So, when I multiply by 7x, I also need to divide it by 7x. Here, what do you want to match? Also 7x and divided by 7x. So far, so good. See, if you use different color, you're clear that's what you divided by, and then you multiply by that. So you always divide or multiply by the same thing. So you're not changing the expression. You're not changing the limit. Okay, and then we're ready to evaluate the limits. Because this guy, sine u over u is 1, u over sine u is 1, u over sine u is 1. Oh, and then here. Don't put 0 over 0 here. If you put 0 over 0, you just ruin what you have done. That guy, cancel. And then 4 over 7 times 7, 49. Okay, so we get this answer. So far, so good, everybody. Okay. So, number part C, I hope that for part C, you can try to pause the video. Oops. So you can try to pause the video here and try to work on it first. Okay, so let's see. Let me make it bigger. Okay. And I have more space. Okay, what is the first step? We want to, they change in terms of sine and cosine. So, what is tangent? Well, that is sine over cosine. Oops, sorry. I should put the x after the 7. And tangent is sine 2x over cosine 2x. Every time when you see fraction in a fraction, simplify it. Remember, a over b over c over d is a over b times d over c. So sine 7x is on top, cosine 7x is in the bottom, sine 2x is in the bottom, cosine 2x is on top. Okay, next. You're gonna split the factors. Sine 7x on top, cosine 7x bottom, cosine 2x on top, sine 2x bottom. See, I split all the factors. Next, we're gonna match. Sine 7x, what do you want to match? Oh, we matched 7x there. Yeah. So when we divide it by 7x, we also multiply by 7x, right? And how about cosine 7x? Do we put a 7x here? No. Why? Cosine, when you plug in 0, what's cosine 0? Cosine 0 is 1. So 1 is okay to leave the 1 in the denominator. So you don't need to match anything. When you see cosine, just put a 1. Because cosine 0 is 1. 1 is okay to be in the denominator. Sine is not okay because sine 0 is 0. So it will be a problem if you have sine 0 in the denominator. But cosine, don't need to match anything. Just put a 1 here. And then sine 2x, see, I matched the 2x. And I also divided by 2x. Alright, you see? Then we're ready to evaluate the limit. Because the first guy is 1. And cosine 7x, cosine 0 is 1. Cosine 0 is 1. U over sine u is 1. And here we cancel the bad guys. 7 over 2. So the answer is 7 over 2. So far, so good, everybody. Do you have the same answer? Good, let's continue. So I strongly recommend you to pause the video and try each problem first. Then play the video and check your answers. Okay, it's good to practice a lot. And we do have a lot of examples, so I hope that you can also have a chance to practice. Okay, so it's not in terms of sine, cosine, so let's change it. What's cotangent? Is cosine over sine, right? Oops, sine of the same angle. Be careful. Okay, so now we're gonna split the factors. Okay, so x on top, and then cosine 2x here. Okay, here I'm gonna put the sine 2x under the x. Okay, I want to group them together. Do you know why? Why do I want to group them together? Because see, this is sine 2x. You want to match a 2x over there, but you already have the x. So you don't really need to like match a 2x there because you already have the x. You can put the x here. It's like, okay, you need $10, but you already have $5. You want to borrow $5 from the bank, right? You don't need to borrow $10 from the bank. So it's like here, you want to match a 2x, but you already have the x. So you don't need to add the 2x there. You just need to borrow the 2. Okay, everybody? Yes. So here, we group them together. That's why I asked you when you try to match the numbers or match the things, you use different color. Because here, I already have the x. I only want to match the 2. So when you multiply by 2, you divide it by 2. See? I'm not matching the 2x. I'm matching just the 2. Okay? And then cosine 0 is 1. So it's okay. We leave the 1 here. Okay, so here, we don't need to put anything. So then we just put the 1 there. You see, everybody? So we continue. Okay. So now u over sine u is 1. Cosine 0 is 1. And this is 1/2. So the answer is 1/2. Is this very easy? Okay, some of you might ask, okay, what happened? I want to borrow $10. Even though I have $5, I still want to borrow $10 from the bank. That's okay. You can do that. So you put the x here, right? And you do sine 2x here, and you do cosine 2x. And when you match, here, you know, you're gonna multiply by 2x. Then you divide it by 2x. You put the 2x here. And then here you match the 1. See? Now when you evaluate the limits, x and x cancel. Don't forget to cancel them. You still have 1/2 and then times 1 and times 1. So you still have the same thing. It's okay. I'm just worried about sometimes students put the x here and then they put the 2x here. They forgot those 2x to cancel them, and then they get a 0 as the answer. I'm just afraid that students may make this mistake. Yeah, I have period students make this mistake before. So I'm just, in order to make things easy, so I ask you to, if you have X, just put them together. Don't need to match them. Okay? Let's continue. Alright, so how about this guy? Well, let's factor it. Okay, we have 2 sine of 2x minus 1. Can we factor the denominator? Yeah, that's x minus 1, x minus 6. Right, everybody? Alright, now we're ready to split. Oops, sorry, x goes to 1. You see, when x goes to 1, what's x minus 1 goes to? So x minus 1 goes to 0. Yeah, then it's sine 0 over 0. So that's how do we split? I have 2x minus 1 there. Do you see the x minus 1? I know I'm gonna match 2x minus 1 there, but we already have the x minus 1. See? We already have the $5. We don't need to borrow $10 from the bank. We just need to borrow the $5 from the bank. Okay, so we split and we can group them together. Now, let's start to match. What do we need here? We need the 2. When you divide it by 2, you also need to multiply by 2. But here, what do I want to put it here? Think about it. When we plug in 1, well, 1 minus 6 is -5. -5 is okay to be in the denominator, so we don't need to match anything here. So just put the 1. Okay, so what is that? Well, the answer, this is 1. This is 1 over 1 minus 6 is -5. And we have the 2, so we have minus 2 over 5. So far, so good, everybody. See, all the problems work the similar way. As long as you follow the steps and do it step by step, you can get the answer. So, practice more problems and get used to it, okay? Alright, next. So, when you have cosine something minus 1, okay, so cosine 0 is 1, 1 minus 1 is 0, so you have 0 over 0 here. But whenever you see cosine something minus 1, think about the conjugates, because it will help us to change to, in terms of sine, okay? So we multiply by the conjugate. Okay, so when we multiply the conjugate, what do we get? Well, the top, a minus b times a plus b is a squared minus b squared. So it's cosine 2x squared minus 1. And then we have 7x squared cosine 2x plus 1. Okay, what's cosine squared minus 1 again? Well, we always remember, no matter what the angle is, sine squared plus cosine squared is 1. So cosine squared minus 1 is negative sine squared. So this is negative sine squared, but the angle is 2x over 7x squared, and then cosine 2x plus 1. Okay, let's see. How do we split? Alright, I have the negative, I have the 1 over 7, so the coefficient, I put them together. And then I have sine 2x. It's actually 2 copy of sine 2x. Now, do you see the x squared in the denominator? I'm going to put them here. See? I know I'm going to match the 2x there, but we already have the x. Let's put the x there. And then we have the cosine 2x plus 1. So this is how we split. So far, so good, everybody? So when we match, let's use a different color. Okay, what do I want to match here? What's the u? That's the 2x. When you divide it by 2, you also multiply by 2. Here, we want to match the 2, so multiply by 2 again. Here, what do you want to put it here? Cosine 0 is 1, 1 plus 1 is 2. 2 is okay to be in the denominator, so we don't need to match anything. And here, we have nothing to add more, so we just put 1 there. Okay, so the answer is, oh, let me use the orange color back. Okay, so this is minus 1 over 7, 1 over 2. Be careful, cosine 0 is 1. 1 plus 1 is 2. Okay, and 2 times 2. Oh, I can cancel one of them. So my answer is negative 2 over 7. So far, so good, everybody? Okay, for G, I hope you can pause the video and try to work on this problem on your own first. Have you done? Let's check our work. So 1 minus cosine, well, difference. So you think about its conjugate, right? So it's gonna be 1 plus cosine 6x. And you multiply by the conjugates on the numerator and denominator. Okay. And now the top, a minus b times a plus b is a squared minus b squared, so 1 minus cosine squared. Okay, so the bottom, x sine 3x, 1 plus cosine 6x. Okay, what is the top? Well, 1 minus cosine squared is sine squared. So I hope you're familiar with this trig identities, okay? So this is sine squared 6x. So don't change the angle, it's still 6x. And then x sine 3x. Okay, now let's split. Well, we have 2 copies of sine 6x, so put it down. And the bottom, oh, I have the x. See, I know I have an x, so I put the x here. Then I don't need to match many things later. And then the sine 3x, I put it here. The 1 plus cosine 6x, I put it here. So this is how I split. So after you split up, make sure, okay, what's the numerator? Sine 6x times sine 6x, I get sine 6x squared. The bottom, I have x cosine, sine 3x and 1 plus 6x. That is my denominator, okay? So you can check your work to make sure you're not putting the factors in the wrong place. Okay, so let's continue. What do we want to match here? Oh, 6. So we also need to multiply by 6. Here, what do we want to match here? Well, 6x. Well, then we need to multiply by 6x. What do we want to match here? Oh, 3x. Then we divide it by 3x. What do we want to match here? See, cosine 0 is 1. 1 plus 1 is 2. 2 is okay to be in the denominator. So don't need to match here. Alright, finally, we can evaluate each of the quotient. So sine u over u1, sine u over u1, u over sine u1, 1 over 1 plus 1, 2. Oh, don't forget to cancel the bad guy. So we have 6, 6, 3. Oh, 2, 3 give us 6. So the answer is 6. So far, so good, everybody? Okay, so that is how to solve the trig limits. So in the video part B, we're going to talk about the derivatives. Okay, let's continue in part B.